Now we're going to look at how the cosine law is developed. Again, we have an oblique triangle, and the first thing we're going to do is recognize that this side here, since it's opposite angle B, we just call it side B. And I've pulled it out for a reason that'll become clear in just 1 minute. We're going to do the same thing we did with the sine law, and we're going to drop a perpendicular from angle B to its opposite side. And remember again that we create two right triangles when we do this. One on the right and one on the left. And I'm going to call this point here D. What we're then going to do is rename the sides in the two smaller right triangles. So on the left, I'm going to call this side X. And on the right, since the entire length is B and this little piece is X, this side here will be B minus X. What we'll do then next is take a look at triangle ABD, so the triangle on the left-hand side here. And we're going to use our Pythagorean theorem. And remember, the Pythagorean theorem is the hypotenuse squared is the sum of the square root of the other two sides, so c squared will be h squared plus x squared. But I'm going to write it in a different form. I'm going to write it in terms of h squared. So the one side squared is the hypotenuse squared minus the other side squared. We'll then take an expression for the cosine of our angle A in that same triangle. So cosine of A is adjacent x over hypotenuse c. And there's our cosine of A. And we'll rearrange that expression in terms of just x. So x will just be c times cosine of A. And these are the pieces that we're going to use, the hypotenuse and our trig function for cosine. We're going to put that together with some other information and see how the cosine law comes about. Now we're going to switch over to the triangle on the right-hand side. So triangle BCD. And what we're going to do is we're going to take a look at the Pythagorean theorem again. And remember, hypotenuse squared is the sum of the squares of the other two sides. So let's write that out. Hypotenuse is a squared. One side is h squared, and the other side is b minus x, all squared. Once we have this, what we're going to do is we're going to substitute our information from before, from triangle ABD, and we're going to plug it into these terms down here. So we should notice that we have a h squared right here, and we have a h squared right here, and they're the same h in the triangle. So I'm going to replace c squared minus x squared wherever I see h squared. When I do that, this is the expression I get, c squared minus x squared, plus, and these three terms here are just the expansion of b minus x all squared. So remember, b times b is b squared, x times x is positive x squared, and then b times negative x will be minus bx, but then that happens twice, so that's where we get this minus 2bx term. We should notice that there's a negative x squared and a positive x squared, and of course they're going to cancel out. So now I can rearrange this and just put it in order of letters. So my a squared is b squared plus c squared minus 2 times b times x. But remember, we had this expression here, x was equal to c cos A. So now I'm going to take the c cos A and replace it here where I have x. So here's our cosine law. A squared is just b squared plus c squared minus 2 times bc times cosine of A. Now this is just one form of the cosine law, so we have to remember that we're able to write it in three different ways. The one we just developed for a squared, but we could do another development. Again, same as before for the sine law, just drop a perpendicular from A to side A or C to side C, and we'll get the other two versions of the cosine law. But if we know the pattern here, if we notice it, we have one side here, the other two sides are squared, and on the right-hand side, the sides again show up here, and the angle here correlates to the side here. So if I try to do my b squared expression, we notice again the pattern. My side b is here, a is here and here, a is here and here, and since I'm solving for b squared, I have angle b. And in the last version of the cosine law, c squared, since c is on this side, a and b are on the right, a and b show up here, and angle c is here. And those are our three versions of the cosine law.